So we saw in the experiment which J.J. Thomson did, he said that he found out that electrically charged particles, negatively charged particles were present in the atom. But we know that atom on the whole is neutral. What does this suggest? That there must be equivalent amount of positively charged particles also present along with the negatively charged particles. And these particles, how did we come? This led to the discovery of the protons. Okay. And who was responsible for this? An English, this E. Goldstein was responsible for this. Okay. And what he did was, he found, when he was doing the experiments with his discharge tube experiment, he found that along with the cathode rays, there was another stream of particles which were moving just in the opposite direction of the cathode rays. That means what he did now, that in the same discharge tube, he just changed the position a little. He took a perforated cathode. This is a perforated cathode. This is connected to the negative. This is the anode, and this is the cathode. This is connected to the negative terminal, and this is connected to the positive terminal. The pressure and the voltage were the same. The pressure was also 0.01 mm of mercury, and the voltage over here 10,000 volts. Okay. Now after that he found out that from the cathode, rays were moving towards the anode as usual, as found out by Thomson, but along with that there is another opposite stream which is moving in the other direction. So what he did, he took a perforated cathode, a cathode with holes in it, and he placed it in the, he removed the position from here to here, means he moved it towards the center. And then fluorescence was caused. Here also fluorescence was caused, and over here also fluorescence was caused. That means what? There is a stream of particles with oppositely charged particles which were moving from anode towards the cathode. The flow of the particle was just opposite, means from anode to, this flow was from anode to cathode. The previous was from cathode towards the anode, now it is moving from, and he called these canal rays. The canal rays moved from anode to cathode, or anode rays. Okay. Now what were they had the same type of properties as the cathode rays, but some differences were there. They traveled in straight lines just like, and they produced shadows. Then they produced fluorescence on the zinc sulfide screen. These were the same like electrons. They are affected by magnetic and electric field, but in the opposite direction. The electrons or the cathode rays were attracted towards the positive pole because they were negatively charged particles, and these are positively charged particles, so they are deflected towards the towards the positive pole, that is towards the anode. Then they are made up of positive particles. The cathode rays were made up of negative particles, and the anode rays are made up of positive particles and possess kinetic energy. They have motion, and their E by M ratio, this is another difference. They don't produce X-rays. Electrons produced X-rays when they hit a tungsten metal, but here they don't produce X-rays and they don't ionize the gas. Their E by M ratio, this is also a difference. Their E by M, the charge by mass ratio, differs from gas to gas. Naturally, the mass is different for different gases, so the E by M ratio differs from gas to gas. These are ionized particles, remember. Okay, what happens when a high voltage is applied to a gas at low pressure? It ionizes, rips off the valence electrons, and it rips off the valence electrons and produces ionized particles, positively charged particles. It was these positively charged particles which were moving in the opposite direction. So the E by M ratio differs from gas to gas, and its value is much less than that of electron. is maximum when hydrogen is taken. Hydrogen is the lightest of all elements, so the denominator, the mass will be less. Naturally, the E by m value will be highest, maximum when hydrogen is taken for the in the discharge tube. From this, what was concluded? That proton possesses unit positive charge. It has, how do we write it down? Proton possesses unit positive charge. In electron, -1, the mass is 0 and proton has unit mass. That is equivalent to the mass of hydrogen. Mass is the same as that of hydrogen atom, 1.672 into 10 to the power minus 24 grams. Proton resides in the central part of the atom. This he said, but Thomson gave another model after the discovery of electron and proton. Remember, till now the nucleus was not discovered, and the neutron, existence of neutron was also not found. So what happened? J.J. Thomson gave a plum pudding. J.J. Thomson gave a plum pudding model for this. And according to him, he said that atom is a charged sphere. It's an ocean of protons, and the electrons are embedded as the plums are embedded in a pudding. When your mother bakes a cake or makes a pudding, you see the dry fruits on top of it. Okay, so J.J. Thomson's model of plum pudding he said that it is a sea of protons. It's a sea of protons with electrons embedded like plums in a pudding. It's like how when if you cut a watermelon, the red part is proton and the black seeds, these are the electrons. So electrons are floating in a sphere of protons. That was given by J.J. Thomson. We call it J.J. Thomson's plum pudding model. Rutherford, working on other experiments, found out the existence, exact position of the nucleus, and he said that he gave the actual shape of the nucleus. He took gold leaf. Gold is the most malleable of all metals. Most malleable means you can get very, very thin sheets of gold leaf. So he took, his experimental material was gold leaf.